All right, thanks. First of all, thank you guys for coming out. I know it's a lot further than the point of the mountain. I hope it wasn't like the wrong direction for most of you. Item of business, you're welcome to the Coke machine over there. If you get thirsty in the middle of this, feel free to go take a drink. And like you said, we'll have an intermission as soon as the food gets here. Because I know that if we don't, you'll all want to stand up and go eat. What we're talking about today, lessons from adopting Go at Qualtrics. We've been fortunate here to be able to take Go from basically nobody to a lot of developers. And we're here to talk about what our experience has been doing that, what the challenges have been, and hopefully talk about something that might be useful for you guys at your companies or whatever you're working on. We think it's interesting. Hopefully you do too. This chart is one I pulled this morning from the Git history of our Go project. It's a list of the active Go developers measured by the number of unique committers to our Go projects at Qualtrics. This is since probably 2015. And you can see that it's gone from 1 in 2015 in about May to over 30 now. And for the sake of transparency, we're doing Nathaniel an injustice because we cut all of his commits off the beginning. He was the only committer for a couple of months.
Okay. And he would be like back here a little bit, you know, 1, and then it kind of went away. Then we caught momentum later, but
got a lot of good
we're grateful,
Nathaniel.
Grateful for those roots.
Thanks, though. This slide is the number of commits. It's the same kind of chart, but it shows the commit history. So you can see that we went from, even though the developer chart's been kind of linear, the number of commits has gone from not very many to kind of an explosion of commits around the middle of 2016. So what we want to do today is talk about how we did this and hopefully how you can do this too if that's the position that you're in. Can you guys hear me okay? Okay.
Cool. All right. So our goal is, you know, kind of looking back at the meetups that we've done. I've attended several of them. It's a great group that we have. We've done several technical topics. This is not going to be as technical. We will talk some about microservices, about kind of the life cycle of software development, but it's not as technical in the code. But we do think it'll be very practical for you. And like Tyler said, you know, if you are in a position where you want to have Go gain more traction at your company, this will certainly help. If you have a lot of Go developers already, but you just want to, you know, ensure that they're writing best practices, it'll also help. Or maybe you don't write Go at all, and you're trying to see if it's a good fit. Whatever the case.
How many of you guys work at companies that write Go exclusively? Majority of your code being Go. Okay, that's like not very many. How many work at companies that write some Go, but mostly not Go? Do you guys wish that your companies wrote more Go? Okay, let's try to figure out how to do that today.
Yeah. So before we go into what makes Go just so incredible, it's probably worth mentioning here that Go is not, unfortunately, a silver bullet. That being said, it's close. So what we're encouraging here is use Go for what it's good at, right? At the problems that it's good at solving. And with that, we'd say that everyone has problems that Go is good at solving. So therefore, you should try to use it for those things. It's kind of a roundabout way of saying that, you know, we really like Go, but just remember, it's not always the best.
They say, like, always pick the best tool for the job. Always pick the best language for the problem that you have. If you're coming at it from the other side, it's find the problems that your language solves and focus on those, right? This is going to be the rundown for the rest of our presentation. We want to talk basically about 6 things. Number 1, we want to talk about where we were, where we came from, and the kind of environment that made Go a viable option for us at Qualtrics. We want to talk about why it fits so well in that environment, what made Go a good choice given our problems. Third, we want to talk about how we got the initial buy-off. How did we convince the business that Go was a viable choice in a stack that was primarily traditional languages like PHP and Java? Fourth, once we got some buy-off to try this, how did we get to 30 developers like we showed on that first slide? And That's going to be the interesting part to look forward to. Fifth, what did we wish we knew? There's some stuff we didn't do perfectly. There's some stuff we wish we'd have known when we started. Talk a little bit about that. And then sixth, where do we go from here? We're not done. We still have developers at Qualtrics who aren't writing Go code, and we wish that they were. How are we going to get that to happen? Here's some story. We're in the middle of 2015. This is about when we started thinking about using Go. And the life of a developer at that moment was maybe characterized by some problems that you'll be familiar with. We had essentially a couple of monolithic code bases, just a couple of code bases that everybody worked in. Like, how many of you guys have had this problem at some point in your career? Yeah, it's like a reasonably common problem, and it sucks. It sucked for us too, because everybody's in the one code base. We got to the point where, like, you'd try to go merge your branch, and you'd pull the latest of master, and you'd go to merge your branch, and it wouldn't merge when you tried, or wouldn't push when after you'd merged it, because in the time it took you to pull and merge and push, somebody else had their changes in on top of yours. It was like a huge pain. Another one of the consequences of monolithic code bases is that everybody focuses on their little piece, but nobody knows the whole thing. There's a couple of people who have a lot of familiarity with the deeper pieces of it, like Nathaniel was our resident expert at everything. But most people aren't Nathaniel and don't know what most of the code is. They focus on their little piece, but because it's a monolith, they get drawn into code that they don't understand, spend a lot of time reading code that they're trying to figure out, but that affects them in some way that they need to understand to get their job done. Tons and tons of context swapping between code you understand and code that you don't. Because we had monoliths, there was like one build process for the one or two code bases that we had, which meant that the people who managed them, Nathaniel, understood them, and literally everybody else didn't. So if you wanted to know how your code was going to get to production or when, you didn't really know. You had to do some investigative work to figure that out. With monoliths where everybody works in with dozens of developers, there's tons and tons and tons of changes, which means every release has a bunch of dangerous stuff in it. And you don't like that, so you don't do very many releases. You have this extravagant testing process and quality assurance, and it takes forever to get a release out. And it's just all around not awesome. You don't get it right, you find bugs. That means hotfixes are common. It's this unvirtuous cycle of just creating problems in your code base. The summary here is that we had software development lifecycle problems. We had a lot of code. It was doing great things for our business, but it was a pain to work in as a developer because of the problems that we talked about. It's just too large to work in effectively. We had serious ownership problems. Nobody knew what code was theirs and what wasn't. The lines were blurry. And then there were procedural problems. You didn't know quite what the process was to get your code deployed, to get your changes out, this kind of stuff. Monitoring was kind of a black science to most of the people who are here. The good news is there was some hope. A handful of people recognized that this problem was a problem, that we weren't going to be able to scale forever doing this, and started a conversation about what we could do to solve this, what kind of changes we needed to make to keep things running smoothly, to keep our business going. That was actually good because it meant that people were thinking about the problems. There was some people were welcome, were ready to see a change and see new practices. The business needed more agility, as we say on the slide, so that we could release new features. A customer had a bug that they wanted fixed. They can't wait a month and a half for the next monolithic release. Microservices and the architecture and infrastructure to support that was starting to be a thing. We had Docker in production. We had a pipeline for getting a Docker container deployed. We had Console in production for doing service discovery. Are most of you guys familiar with those two tools? Yeah, so those help a lot when you're trying to get away from a monolith. And we were fortunate enough before we started doing Go to have those tools available to us. And finally, the bad word of the day, there were several Node.js services. How many of you guys were Node developers before you were Go developers? Yeah, it's like nobody wants to admit it, but everybody knows it's true. The benefit we had from Node is that the people who were writing Node had already proven to the Qualtrics company that it's possible to use a new language and integrate it into the existing stack. And like, this isn't something that's completely intuitive or obvious up front. It's something that really has to be proven. And we were fortunate enough to let other people do that before we came on board with Go.
So that will hopefully give you some context on, where we're coming from, where we were in 2015, and this is going to drive us kind of forward in reflecting, reflect.value, on how Go was able to solve those problems that we noticed. So first of all, it really wasn't Go. Like Tyler was talking about with microservices and Node, they really solved a good number of these problems that we had. For example, our code bases were dramatically smaller. And as a result of that, they're easier to work with. The second point there, we were forced to diffuse the ownership and assign microservices to teams, right? So this team owns, say 2 or 3, sometimes more microservices, and at least there was ownership there. So a new team member could join on, and you throw them at a microservice, and they'd really just own that microservice, understand how it works, and be able to contribute to the team, unlike a monolith where you just try to contribute anything, right? You try to understand, like it's so hard to understand the breadth of it all that you can't really make, lasting changes. So that was a big step forward with microservices. In addition, the third point there is that each microservice had its own build and deploy pipeline, and that really helped us to at least our code was checked, our checked-in code was built, it was tested, and so on. However, some problems remained, even after we had switched to this microservices architecture. So even though our code bases were smaller, they were still complex. A lot of them were in Node, and for this reason, people were using different testing frameworks. They were approaching the problem in different ways, and Node, has a sense of like you can solve the problem in many different ways, whereas as we'll move into Go is more of there's one way to solve this correctly. And then while our builds and deploys were more frequent, they were still slow. In fact, we had some Node JS builds that were taking 40 minutes, right? And that's not really practical when you want to hotfix something in production. You'd rather roll back, which takes, maybe up to an hour, and then move forward later on, rather than with Go, you can just 5-minute hotfix and you're in production, right? So certainly that's going to enable so much more and solve more of these problems.
Yeah, so the question is, how do you solve the problems with your software lifecycle that you can't solve with just microservices, right? Jared talked about the problems that microservices do solve, but as we just saw, there are some that microservices alone in some random language don't necessarily solve. So how are we going to solve those problems? And for us, the answer turns out to be Go. How many of you guys have read the Go at Google Language Design in the Service of Software Engineering essay? I want to see hands.
I can pull it up. It's right here.
All of you guys should read this because it's exceptional. If you want to understand the philosophy and the theory of Go, this is where you want to start. I'd read this essay when we were talking about how to solve some of these problems, and it occurred to me that Go was designed to solve exactly the sort of software lifecycle problems that we had. Rob Pike was nice enough to point them out for us. He said, the properties Go does have address the issues that make large-scale software development difficult. Individual features of a language don't address these issues. A larger view of software engineering is required, and in the design of Go, we tried to focus on solutions to these problems, meaning the software engineering lifecycle problems, not necessarily the coding problems. We've all heard people who are like, I can't use Go because Go doesn't have generics, right? Like, you can use Go without generics. Generics might solve a day-to-day interesting technical problem, but they don't solve a software lifecycle problem. And many of the properties Go does. The essay continues. These issues include slow builds, uncontrolled dependencies, each programmer using a different subset of language, poor program understanding, duplication of effort, these are the problems we just talked about having. And Rob Pike is telling us in 2012 that Go solves them. That was our first clue that we were on the right track here. I want to talk about this slide a little bit, actually a lot. First, I want to point out that we didn't understand this in 2015, but this is what we understand now and how we know it's our explanation of why Go solved the problems that we had. Does that make sense? First of all, Go has a lot of seemingly small properties that Rob Pike pointed out that add up to meaningful software lifecycle improvements. And thinking about those, iterating through those, and considering the consequences that they have, help you to realize the impact that those features at an individual level will have on your business. Before we go any further, I want to kind of get a sense for where we're all at. How many of you work at companies that are in this process somewhere, as opposed to being happy with your monolith or being happy with your microservice infrastructure you've already succeeded at? Okay, so quite a few. Hopefully this is interesting to you, and hopefully it makes sense. If at any point in this you have a question about how we did this or how it applies to you or anything like that, like interrupt us and we'll stop. By the way, the food's ready. We'll stop in 2 more slides and we'll go get it. Sound good? Okay, software lifecycle improvements. Build times actually make a difference. You as a developer don't like to sit there and wait at your computer while you wait for your build, but like if it takes 5 minutes, you're still gonna get stuff done, right? If it takes half an hour, like you're just not gonna build as often, but you'll still get work done. However, if your builds are fast, the way you think about deployments will change. It becomes an option to deploy your code to, say, fix a bug, if it's a clean fix. We had an issue, I want to say last Thursday, where one of our Go services was the cause of an incident that we triggered for one client. And it took, between the time the issue was identified, we understood what the problem was, and until it was fixed in production worldwide, was 9 minutes. If your build times are fast enough to do that, and your code is simple enough to code review with confidence, and your tests are good enough, your incident response can be like that. It doesn't have to be a 1-hour process with everybody at the company, because you can fix it fast. Second point, homogeneity. I don't know how to pronounce that word, but the idea that there's consistency across the language, right? We see this all over in Go because it's so convention-based. There's Go Fmt that makes everybody's code look the same. The impact of that is that you can go into some random library you found on GitHub and actually understand the code, or even better, you can go to your coworker's code that's in some other service and understand that too. You don't have to shift your entire mental model to read the code. Additionally, you've got stuff like testing tools, linting tools. You can probably run the tests for any Go project you find on GitHub by running Go test, right? You can't make that strong of a guarantee for most other languages. That turns out to really matter because it smooths the development process. It helps everybody be on the same page. It just makes life better as a developer. Another interesting point there is that it makes it easier for your manager as a business stakeholder to move people around. If you're on a particular team working on a Go service, it's a lot easier to move you to another team working on another Go service than it would have been for, say, a Java developer, where the syntax, where the coding style in the different services might not be remotely similar. We've seen that, and actually makes a meaningful difference for us too. The third point I want to make is about the standard library and just about Go APIs in general. The standard library in Go is phenomenal. It's thorough. One of the first first applications we ever wrote at Qualtrics in Go, or that I ever wrote, we wrote in Go specifically because the standard library could generate normal distribution, random numbers with normal distribution, an exponential distribution. The standard library has all sorts of clever APIs that do the right thing and solve real world problems. They solve problems you maybe didn't know you had. How many of you are familiar with the monotonic time API in 1.9? Yeah. So the story with this is fascinating. It was proposed in a GitHub issue that Go add API for tracking monotonic time, so that like if you start a timer before, say, daylight savings time or before a leap second, and then you end the timer afterwards, you don't want to get a negative duration. That doesn't make any sense. So it was proposed that we add a new API to the Go standard library to handle this case. What they ended up doing instead of that was making the implementation of the existing time.since API better to automatically handle that case. That's a problem that most people don't know that they have, but the Go standard library solves it for you regardless. That's valuable as a business, right? Because it ends up giving you reliability in your code base beyond what you knew to ask for. I've worked in PHP, I've worked in Java, and I've worked in Node, JavaScript, and I've never seen a standard library remotely this good in any of those languages. So the point here is that the individual features technically of the language add up to meaningful business value if you kind of think through how that will happen.
All right, so we've explained pretty well now that microservices for us were one step forward, and adopting Go was another because of all these incredible features of the language itself. Combining the two together is really one of the keys to our growth. So Go is truly proven for microservices. It's a simple language, has this robust standard library as Tyler talked about, but it still remains simple and easy to learn, and your code is consistent with other Go developers. I mean, just think about everything that's built into the standard library, as we've shown here. You have REST and JSON support. You have a common web server that you're going to be using for all of your Go projects. The same unit testing framework. Just all of that is built in. And we try to list some of the technologies that we use in other languages at Qualtrics here. But with Go, it's just all built in. And like Tyler said, as you move across projects, you don't have to learn, say Maven if you've used a different dependency manager before. And additionally, Go is really proven for operational simplicity, at least for us in our experience. Because it's one of the potential problems you have with a microservice is, what you could end up with is a slew of microservices that are all terrible and hard to maintain, right? And so instead of having just one terrible and hard to maintain thing, now you have, 20. And with Go, at least you don't have to worry about that. It's been a breeze for us to run. I mean, obviously we still write buggy code, just like all of you, and just like every other engineer. But Go makes it easier to either catch that at runtime, with static typing, compile time. Yeah. And then also just to debug issues in production. It's easy to get visibility into your Go services with, things like Prometheus and so on that really make operations very easy. And here we pointed out, some of our Go images that we run in production, and we just love how small they are, right? That we can, sometimes build something locally into a Docker image and then pull it down in our staging environment, run it. It's just so quick that we don't have to worry about the, sometimes gigabytes of size of these code bases that we also run at Qualtrics. I think our largest one here, 31 megabytes, is because it's running a web server and has Angular, JS, and static assets that are inside.
Obviously,
right?
Of course.
So this has just been a great thing for us, and we really feel like it'll enable us to do things like elastic scaling. We're currently not doing a lot of that at Qualtrics, but we're in the process of adopting that. And small images like this will really make Go stand out in that kind of environment where you can just start something up, shut it down very quickly.
This slide came from a presentation we did internally to other developers, and other developers who were familiar with Docker, already using other languages, used to gigabyte-sized Docker containers. We showed them this slide, and a lot of people came up to me afterwards and thought we'd essentially cheated, and that there was no way our containers were actually 10 megabytes. It was pretty funny. With that, let's take a pause and let's go get the food. I'm sure you guys are hungry. All right, so we've talked about where we were at as a company when we started thinking about Go. We've talked about the properties Go has that makes it valuable and useful for us. Let's get into a little bit about how we were able to sell the business, how to get Go entrenched at Qualtrics. Excuse me. The first sign that you need to use Go is that you're building a microservice. Chances are extremely high that if you're building a microservice, you should use Go. So most of you probably have more opportunities you can count to use Go. You don't need any advice on that front. Here's the thing. Here's a list of the kind of the things that we learned that helped Go succeed here. The very first thing that you kind of have to do, and I assume that this is something you've all done since you're at a Go meetup, is learn Go well enough to sell it. If you don't understand Go, if you don't know the philosophy of Go, if you don't know the syntax of Go, it's going to be really hard to convince your manager that he should trust you with this new language. It's important. It's more important than we thought it would be to understand the idioms of Go. Because Go as a language is interesting. Its syntax is kind of cool. The concurrency is neat. But the real value of Go is not in any of those things. It's in the experience that's gone into the design of Go. So make sure to be familiar with why Go is the way that it is. Think about the problem set that Go would be useful in. And just become familiar with Go kind of in principle. Learn it well enough to sell it. For us at Qualtrics, this meant spending time outside of work, for those of us who did this, to learn kind of that kind of thing. Do personal projects outside. I wrote my first Go project in probably 5 months before we started using it here, just to try to figure out how it was going to work. What problems at Qualtrics could I make Go fit for? That's the kind of thing you have to know before you can really move on. Yeah, question.
Did you start looking at Go before you recognized all the benefits that come from Go?
Did I start looking at Go before I understood the benefits that came from Go? The answer to that is yes. I kind of like low-level language, programming languages, compiler, that kind of stuff. That really is entertaining to me. It was curiosity that got me started with Go. Somebody had mentioned it, and I spent a weekend learning it. This was in January of 2015, full 4 or 5 months before we did any of this stuff. Does that answer your question?
Yep.
It wasn't this problem drove us to Go. It was arriving at Go independently and recognizing that it was the solution to this problem when it came up. Excuse me. The second thing to do is start with something small, like at work. Find a problem that you have at work for which Go would be a good solution, and do it. Like, if you can get your manager's approval or get buy-off from your company, then that's great. But it doesn't really matter. Pick something you can do in a couple of days or a few hours and just do it. We did this with one of our services that we had. It was kind of a static asset server type thing, loaded stuff from S3, did some general transformations, returned it to the client. We had an existing service that did this. It was in Node, and it's just not that complex to read stuff from S3, right? So I rewrote that service in Go after work one evening, put it in a Docker container, re-implemented the same API, put it in production next to our Node service, and didn't tell anybody. And the next morning, the metrics for this new service, or this existing service, were like, half the time they were slow and half the time they were fast. It was really fun, but it was cool to be able to do that in basically a day. Once people recognized what had gone on, it helped tell the story of Go really, really, really well. Pick something small that you can run with and prove that it's going to work. This gives you a chance, even for a small project, to flesh out the deployment pipeline, kind of experience some of these lifecycle benefits, and compare with the status quo, whatever you're using at work. I can't help but read this quote because I think it's awesome. This came from an interview from Ryan Dahl, who is the creator of Node, in an interview he did last week. I'm just going to read it. Quote, he works at Google now. He doesn't work on Node. If you're building a server, I can't imagine using anything other than Go. I think Node is not the best system to build a massive server web. I would definitely use Go for that. And honestly, that's basically the reason why I left Node. It was the realization that, oh, actually, this is not the best server-side system ever. I would like to go to other things. So that plus the fact that Go came out, and I didn't see Node as being the ultimate solution to servers. Thank you, Ryan. I couldn't think of anybody better to say that than you. This is an example of how comparing with the status quo is actually really beneficial. If Node is entrenched at your company like it was at ours, everybody's already on board with Node, and you can show that Go is better than Node, then it's a pretty easy sell from there.
All right. So once you have, something small like the static asset server for us, it's time likely, to get some buy-off from your manager before you're going to start something that's a significant server in Go. We did have some help in this regard because we had some good experience internally from that project. We also were using Go in a third-party sense because we were running Docker and console, as we've mentioned. And it also wasn't our manager's first exposure to Go. He had heard about it and never used it or written anything in it. But he did mention to us that like the engineer side of him really was excited about us trying it. So all we really needed to do for him was convince him of the business side. And really what we've talked about to this point is like, are those business reasons why you would want to use Go? And we kind of just collected these together into a proposal, and that's what we presented to our manager. I think I do. And really one of the main challenges we had to establish for him in that proposal was that Go is not just, another trendy hipster language. It really had some strong footing in from Go and also just its trajectory. The 44 here, we're not sure how entirely accurate that was. We were trying to kind of collect that, and lots of articles said different things. But at least the 20 and 16 are posted on their website currently. And obviously it doesn't show signs of slowing down anytime soon. Other indexes will have it in a different place, maybe number 10, but truly it's catching on and doing very well. And this helped us to sell Go in that regard.
How many of you guys work at like cloud software companies? What do the rest of you guys work at? What kind of work do you guys do? Yeah, I know where you work. Databases. What about the rest of you guys? Yeah? Vivint Smart Home, okay. Where at? Proofpoint? Okay, cool. Sorry? Volumetrics. Cool. So Go is super, super useful in cloud software. If you work there, you should definitely be using Go. If you work not in that field, you should also probably be using Go, but it's going to take a little bit more work to figure out how. Once we've established that our manager is comfortable with the idea of Go, has got to the point where he's willing to let us try something meaningful, the next thing that we had to do was actually prove that it was going to work. Build a service that is a business critical service, something that has real world impact to the bottom line, to customers, something that's going to matter, and deploy it to production. We did this with a service called the FieldSet Cache. It's a service that handles caching for dynamic analytics queries. So people will construct whatever queries they can think of that they want in their report, issue the query. It might be fast and it might be slow in the database, but in either case, we'll cache it in this cache so that if they make it again, like say they refresh their page, they'll get the data more or less instantly. This was a service that wasn't really super difficult, but it turned out to be more complex than we thought it was going to be. And we chose to do it in Go. Chose is maybe not the right phrase. We forced the issue and we asserted that we were going to do it in Go. And it ended up being fine. This now sits in front of all of the reporting products that we use. So every query you make for analytics will go through this cache. And you wouldn't believe how powerful a statement it is to turn to somebody and say, look, some odd huge number, 100% of our analytics queries touch Go code and have been for 2 years, and you didn't even know. That's a really impactful thing to be able to say to your business when you're talking about trusting a technology. That really helped. You can also take the deployment process that you learned for your small toy service and productionize it. Once you have a productionized deployment pipeline and manage your buy-off on the on the technology of Go, it's pretty easy to go run from there in terms of deploying more services or building more things. Building a real service and putting it in production in a business critical path forces you to figure some of that stuff out.
All right, so now kind of moving into how did we take it from here, right, where we had really just a few engineers, there's Tyler, there's me, and just a handful of others writing in Go. And how did we, possibly turn it to that where really a significant number, 30 plus engineers writing Go on a consistent basis? And to do that, there are several things that we feel helped the most. And we're going to jump into each one of these in more detail. But things like lowering the barrier to access so people can start writing quickly, having someone who's excited about Go and willing to advocate it, and then watching for cases where it'll be useful in projects, and then teaching and educating our developers here.
The first thing we found that really helped was to lower the barrier of entry of using Go for some new service, for some new developer. If Go is like hard to use, if everybody has to pay the initial price of learning how to use Go at my company, not many people will do it. It's hard. And you'll end up with Java services or Node services, which nobody wants any of that. Instead, anything you can do to make the barrier of entry lower is going to help you develop more Go at your company. The kind of things that we found really made a difference in this regard. We wrote a little bit of getting started documentation so that when someone came up and said, hey, I want to do my new service, when I want to do my new service in Go, or I'm thinking about trying Go, or I want to learn more about Go, we had an answer to give. That was super helpful. Second, creating tools and libraries that address common needs helped a lot too. Everybody needs access logs, right? And we have a standard for the way access logs should be formatted so that they can be parsed and read and manipulated and that kind of thing. That's a package that we wrote, and now everybody essentially gets access logs for free. That's helpful when you can say that you'll get all of this for basically no upfront cost in your new service. One of the tools that I wrote that was actually pretty helpful convincing people that this was worth a try is a tool called Sherpa, which takes a Go project and generates all the build scripts that you need to get it through the Qualtrics deployment pipeline out to production. What's the next slide? We'll come back to that in a second, but these are the shared libraries that we created. We have the HTTP one for HTTP servers. We have a metrics package so that you can publish your metrics to our internal metrics registry. We've got some libraries for interacting with legacy services in our monolithic code base and over the legacy thrift APIs. That kind of stuff was stuff that basically everybody needed, but nobody wanted to implement. So having done it once and saying you'll get essentially free access to all this stuff removed a lot of excuses for why people didn't want to use Go. I think we should skip that. We're not going to show the Sherpa demo because we're running out of time, but if you want to see it, come ask me after and I'll do it for you.
All right, so moving on to having a Go Evangelist. Tyler for us was this, just being really excited about Go, paying the upfront cost, and then being willing to share that and help others along the way, and really just put in that extra time to go the extra mile to help others start using Go. So this will often start as a single engineer in a company, like it did for us, and then it expands kind of as needed into a small group of Go advocates. So expanded for us, to me, and then to others, to a group now that we call the Golang ecosystem group. I think we have 6 or so members on that team, which is kind of outside of our normal teams, but just a weekly effort where we're doing things like focusing on projects that we can use across teams, building shared libraries, talking more about adoption. We talked about doing this meeting in that that weekly meeting that we had. And it was helpful to have, various people on that team that could contribute different things. Tyler did a lot with the groundwork of shared libraries. And then we had another team member who really organized the group, had us meet, and he also built this developer survey that we sent out to everyone at Qualtrics. And we'll come back to that a little bit. So this, we have our Slack group, which I think has grown from like 20 members a year ago to 61 now, which is pretty cool.
We were really excited when we gave our presentation to our internal developers about a year ago, when we could say we had 20 people in our Slack group. We now have like 61.
Yeah.
So having some good resources and an organized effort to get more people on board actually really pays off.
So here's kind of some of the results from that survey, which was really critical for us to collect data about, what were people interested in learning about in Go? Where were they in their on their teams? Do they have the resources that they needed? And from there, we kind of drove the decisions that we made in that Golang ecosystem group. So, for example, we can see here that the best practices we put together were really useful. But people, especially new Go engineers, were having a difficult time getting started and having the resources they needed. And so we used that feedback and we're able to drive decisions in what we focused on as a group. We also learned, sadly, that people feel like they write Bash more than Go. That was quite disheartening. We do write our own build scripts and do our own operations at Qualtrics, so people probably were drawing from that, like, oh, I wrote a build script, therefore I write Bash. But
so watch, we're going to find services written in Bash.
Yeah, but clearly we still have a lot of work to do here at Qualtrics in driving this adoption, because people seem to prefer Go, but they're not writing it as much as they want to.
Watch for specific cases where Go is a good choice. So if you work in cloud software, like we talked about, the few of you, like everywhere is a good choice because everywhere is basically a microservice. If you're not, there are still options for where Go is a good choice. Like we mentioned a bit ago, highlight use cases where Go is going to look good next to the status quo. If you use a lot of Node, that's like really easy. If you work with a lot of Java, it's less easy. You can't really compete with Java in terms of performance necessarily. That's not necessarily a super clear win, but you can talk about the software development lifecycle stuff. You can talk about the operational simplicity of deploying a Go Docker container compared to your Java, and it ends up being a pretty possible thing to do. We talked a bit ago about the monoliths that we have. We have 2 or 3 of those. One case that we found Go to be an exceptional choice for was pulling out microservices out of those monoliths. So we'd go in there and we'd say, shoot, this thing needs to be refactored. Put in a sprint task to refactor this inside the monolith. You can make the choice to say, look, forget that. We're not going to do it in the monolith. It's going to take us an extra day or whatever, but it's still only 2 days of work. We're going to do this as a microservice. And if you already have the deployment process stuff set up, it's not that hard to sell that story.
So yeah, with that, I guess we could kind of talk through this quick case study of how we were able to split, or at least start the process of splitting at least one of these monoliths. So we have this, what we'll call the data platform monolith, which handles a lot of various tasks. Think about ingesting survey responses, being able to do analytics against those, and storing various things, transforming and mapping pieces of data. So it did a lot of things. That's why it's a monolith and why it's not following the single responsibility guideline from Linux servers, or from the Linux philosophy. So with that, we were able to find opportunities to introduce Go into this monolith as we split it apart. So we've talked a lot about this analytics cache, the field set cache that we built in front of the monolith in order to kind of take the load off of the service. And then this response ingestion piece was really just a sprint task that turned into a microservice. I think that Tyler would rather write a new service than write Java any day.
The ask here was we need to refactor the place where we bring in Qualtrics responses when you take a survey into the data platform. And hey, we have stuff that does this and it's in Java, and please make it support this new feature. And I was like, you're asking me to write Java for this like really simple thing. Forget it. I'm not going to do it. Did it in Go instead. It turned out to really not be that hard. It was like 2 Go files with tests. It's just not that hard to do for some of these simpler things. And it's just been a runaway success ever since.
Yeah, both of these services have caused, very few outages or incidents. I'm thinking like 3 off the top of my head over a year, 2 years in production. They've been great to work with. So then in this ongoing effort to split apart these chunks, like all the things that we saw in this list here, we found opportunities to introduce Go. So Go here is in blue. The yellow-orange is, we'll say, cautionary for Scala. And red is, of course, Java, the warning. So we found a few things here that, obviously these were great opportunities to introduce Go for one, but in terms of splitting this monolith, we didn't like how we were proxying all of our traffic through the monolith in order to split it apart. It's really hard to deprecate something when it's still handling all the work. And also, when you write new functionality into these microservices, how do you give consumers access to them when they're coming in through the same API that they've always hit? So we had another reason to introduce more Go into this architecture. So we wrote what we call the data platform reverse proxy, in which there's a lot of subtleties here, but it has things like load balancing that it can easily hit these microservices. It extracts some of the functionality that's common to the microservices into a single place. And it also gave our consumers the second path into our service, or into this, what was the monolith and now is split apart into a microservice fleet. So it's just another great opportunity where Go really excels, right? It's great with concurrency. It's great for holding onto lots of Go routines and kind of coordinating between services and so on.
Another thing that's important to do if you want Go to scale at your company is teach the developers at your company to write good Go, right? If you have a lot of developers all writing poor Go code at your company, that's not good for Go at your company, right? Like eventually people will catch on. Do informal code reviews or formal code reviews if you can get away with it. We have a guy who's in our Go ecosystem group that helps us with a lot of our Go stuff, who watches out in our code management tool, GitLab, for any new Go repo. And if he finds one, he'll go to the repo and clone it, and he'll do a code review of the code, come up with all this feedback, and then he'll go to the author of that code and say, hey, I noticed that you have some new Go code. Would you like some tips? And more often than not, people are actually really happy to hear that, and they say, sure, I'm new at Go, and I would like to hear how to write better Go. It's something that they really welcome, and it gives us an opportunity to teach them about the idioms. It shows them concrete use cases where they did this, but maybe this would have been better. Instead of being abstract, it's something that's concrete. The culture at Qualtrics, and hopefully at your company, is to write idiomatic Go. If you write Go that works but isn't idiomatic, chances are it will come up in the code review, because we've learned from experience that writing idiomatic Go saves you problems down the line. Like I said earlier, one of the value propositions of Go is in the design that went into Go that spares developers these kinds of problems. Write best practices. We talked about that in the documentation. It helps people when they can look at a list and see, check, 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 check. Oh, I need to do that. We didn't need as much documentation as we thought we were going to need. The internet actually is really good. The Go resources online are already very high quality, and we didn't need anything beyond really this is how the Qualtrics infrastructure differs from the hobby project that you might have done. And finally, one thing that we learned that we didn't expect to learn is that it's counterproductive to mandate a particular opinion. If you say, beyond the idioms, of course, if you say, well, we like doing this, this is our favorite strategy or algorithm for this particular problem, everyone has to do it that way, that's really tempting to do because you'll feel like you're making everybody's code better at your company. But it deprives individual developers of trying new things, coming up with solutions that actually might be better than the solution that you have. One thing that you also shouldn't really mandate is you must use Go. And that's especially hard if you want everybody to use Go. But it means that the small community of Go developers at your company, the smaller it is, the more vulnerable it is. If you have people who are very kind of anti-Go that have to use Go, but they don't want to, that's going to do a lot of damage to the momentum that you're trying to build up. So just let people use what they want and let people kind of organically come join your community as they see the value of it. If Go is as valuable as it really is, and as we say it is, it shouldn't be hard. And we found that that really actually is true.
The only comment I have on that is if you're a company the size of Qualtrics with as many developers as you have, I can understand not mandating a backend language. But if you're a small company trying to be as efficient as possible, like you can't have disparate languages all over the place, right? You have to pick one backend language and you have to run with it if you're 5 developers, 6 developers. Otherwise, it's going to be a hot mess real fast. I don't know. Do you agree with that? Or are you saying it's mostly, was your opinion of don't mandate Go for large organizations? Or if you were to start a new business from scratch and you hired a second developer and they wanted to write one of the libraries in a different language, would you let them?
I think that's a really good question. I don't know that I'm in a position really to answer that very well. Because in our experience, we didn't have a small company. We don't have a ton of languages. We have 4. And we have kind of the resources to be able to use different languages for different tasks. My gut response would be that you probably need to be a little bit more prescriptive if you don't have, if it's going to be too much overhead to run multiple languages. But that's really something that I don't know much about. I would say if you have to mandate Go, then mandate Go. Obviously, I don't have any problems with that personally. Here's an example of some of the best practices we wrote. So it's stuff like accept interfaces, return struct. How many of you guys have heard that advice? It's good advice. You should do it. Connection draining, like make sure that all the connections to your server are closed before you kill the server. Line of sight, like try not to get as deep, try to have as little indentation in your functions as possible, right? Don't nest your success case in like 5 error checks. Check the errors and then just handle your success case outside of that. Table-driven tests, use context responsibly if you can figure out how. Profile your code. Just kind of some good ideas that make sense. This is what I was talking about earlier. People really appreciate having a list like this that they can look at and see, oh, I've never actually considered that this might, have an impact on the maintainability of my code base. Thanks for pointing it out. This is the 5th of the 6 sections. We're about 5 slides away from the end here. So there are a couple of things that we wish we'd known when we started that we didn't know. One of them is that it was going to take some time to get this Go thing going. It took us probably a year between when I started using Go to when multiple people were using Go. And it took even longer than that to have lots of people using Go, to have real production services, have the default choice for a new service to be Go. That's taken a long time, and that's not something I necessarily expected. There are a handful of just random gotchas that people seem to really struggle with. Go path, for some reason, is like the most incomprehensible thing to someone who's not a Go developer. And people fight it to like their dying breath. People want to not use the Go path. And it's understandable, but it screws you over if you don't. Like your testing tools don't work right. Some random tool that you go get it, like maybe Go vendor, doesn't necessarily work if its assumptions about your Go path aren't met. It's been a real battle to just get people to do it and get over their opinion on the issue. Semantics and syntax. Actually, some of the things, like the way that you'd write tests in Go, the way that you'd mock something in Go is a little bit different than in, say, Node. People really want to bring their semantics and their idioms from their other language into Go, and it's kind of difficult to have them not do that. We didn't really expect that. We didn't have any resources to prevent that. We're still learning how to handle that problem. Finally, vendoring. Everybody who's a new Go developer who I tell, oh, you should install your dependencies and then commit them, like freaks out immediately because they think that's inefficient. My code base will be 700 megabytes, which if you committed your node modules, it probably would be. But in Go, it's not really that bad, right? It even leads to some really nice properties in your build process, like you don't depend on the network to do a successful build. You can pull any commit you want and get a reproducible binary. It's actually really convenient. It's not perfect. We'll see what happens with Go Dep, the tool that should be coming up soon, but these are some of the issues that we found people really struggle with. Anticipating questions from other engineers, like you kind of know what people will think about Go before you talk to them, and you ought to have some responses ready to the questions you know they're gonna ask, and you should write them down after they come up so that you can point the next person to ask at your existing answer. We've wasted a lot of time answering the same questions over and over and over and over again. Shared libraries, we should have focused, more on the core components, core functionality than we did. We have some core stuff and we have some really high level stuff that maybe could have waited until some of the core stuff was done. For example, we still don't have a shared package that manages authentication and authorization, which you'd think is like the first thing you do. We didn't do that super effectively.
All right, I'll quickly kind of touch on these and then we can close. So some ideas we had kind of moving forward. First, we have this thing at Qualtrics called Demo My Skills, which is a kind of mandatory project that you do right when you start at Qualtrics. So you learn, how to deploy a service to production and how to, see metrics running and build dashboards, etc. We'd really like to do something with like a Demo My Golang Skills, or like, a training project that people could start with that has heavy documentation and comments that demonstrate our best practices. We think that'd be just a good way to get people started with the language. And similar to that, but actually different is a tailored service template. This is something they talk about in building microservices. Like, what if you could have out of the box, or what if developers had most of the code in place to implement the core attributes that each service needs? So we're thinking here like a repository you could copy and then expand to solve whatever problem it is that you're trying to solve. So just a base microservice that already does things like authentication and logging and metrics, has Prometheus and has build scripts in place and so on, just so that out of the box they have everything they need and then they can push forward. And then I think this is our final slide, just grab bag. I won't go into the details for the sake of time, but just other ideas that we could throw in, common logger, and just be the first to adopt auto scaling and so on, just so we can stand out amidst the other languages as being on the cutting edge. I think that is all.
Yeah, that's it. Thanks you guys for coming. We're happy to take questions at this point. And you're welcome to obviously stay around and talk to us and each other as we go. Are there any questions that you guys have from the presentation? Yeah.
I don't know a whole lot about this, and we operate on kind of a crappy microservice architecture, but do you use some sort of message passing interface or anything between your different services, Java and Go and whatnot?
That's a good question. In our case, we use, so are you familiar with console or service discovery in general? There's two answers to your question. Console answers one of them. Console sets up like DNS aliases for each of your services. So you can hit like analytics cache.service.console and it will take you to some instance of that service. So that's half the answer. You don't, if you just need to make an HTTP request to some instance of some service, you can do it that way. And you don't actually have to know anything about where it is. The second answer to your question, if you have like a queue or like a job queue of some sort, it is helpful to have some sort of message passing interface. We do use both Beanstalk and RabbitMQ and also Kafka in a variety of places. And we move messages back and forth between various services using those, but we don't have anything like super formalized. We've definitely not used that much in message passing between different languages. Does that answer your question? Some of our services use protocol buffers. We have a couple of services that talk amongst themselves using gRPC, but like this isn't something that we've actually standardized. So we've got basically everything you could imagine. Other questions? I'll get you back here and then I'll.
Do you use any kind of structured errors, or are you just string returning, you know?
Structured errors are an unsolved problem at Qualtrics. I kind of feel like they're an unsolved problem in Go. We use a lot of Sentinel errors. Dave Cheney's probably not happy with us, but sometimes that works better than everything else. We do create like structs that implement the error interface if we have some specialized case that we need to carry some context around, but we haven't really solved that problem.
Yeah, it's different everywhere. Seems like every app does it differently.
So I've looked into gRPC has their whatever 13 or whatever error codes, because most of the time, by the time it gets to the top, I need to know, is this a retriable error? And is this an error that I want to pass out to the end user, you know, out through the API? And so I've thought about using just those gRPC. It'll map to internal services. Presumably Google's figured out what error types there are. I don't know, does that sound reasonable? Is there a reason you would or wouldn't do that?
I would think if you're using gRPC to communicate between microservices, then it might make sense. For us, kind of as we've explained, like the HTTP layer is where we're communicating. And so for us, it's all status codes. You have anything to add on that, Tyler?
There's nothing that stands out to me in that idea as like a bad idea.
Yeah,
if you can get everybody, if you're small enough where you can get everybody to standardize on a particular set of error codes, then I mean that sounds like a dream to me.
Quick question: what's your top 5 like third-party Go libraries that you use here at Qualtrics?
I can give my 5. Do you want to give your 5 too?
Sure. Yeah. I mean, we might overlap a bit, but
all right. My 5 would probably be HTTP router.
Yep, I was going to add that one. It's Julian Schmidt.
Julian Schmidt's HTTP router. There's a UUID package that we use in like literally everything. I don't know who the author of that is. Do you?
No, that doesn't ring a bell. I feel like it starts with an S. Like
I want to say like Satoshi or something, but that's something else.
Yeah.
So that UUID package, BoltDB, is on my list.
Level DB is a similar one that we've tried out here at Qualtrics. We use it for a cache, well, persistent cache, right? So not in memory, but yeah.
That's all I can think of. I don't use a lot of external packages, I guess.
Yeah, I'm trying to think of some as well. I mean,
I'll keep thinking. I'll get back to you if I think of more. Nothing. We do it. We have this custom rolled in-house thing. Sorry? Essentially, we use a bunch of internal tools. Sorry? Yeah, it's a mess. You can blame Nathaniel, I guess. We use Rundeck to just SSH into hosts and do the pulling and restarting of Docker containers. We have a bash script that manages kind of the Docker control aspect of that. We have an active project to move all of that into Nomad, but we are not there yet because there's a lot of work to do and a lot of stuff doesn't actually quite work with Nomad out of the box in our infrastructure yet. So it's been a long, long process. Yeah, it's a dissatisfying answer to us too.
I'd say in summary, it's like, think of it like Docker Compose, but we've kind of rolled our own Docker Compose. Just, we call it Docker CTL. And
does that answer your question?
You mentioned that you commit your vendor folder, but you also have a lot of common libraries. So what happens if I update a common library? How do I make sure the up to date?
What happens if we update one of our common libraries? How do you make sure that the people who vendored it in have the newest copy of it? That's also kind of an unsolved problem. We're small enough that it is enough to just kind of announce that we've made a change. And anybody who cares about that change sees the announcement and may go update their code. In some cases, I'll go update everybody's code for them to pull in and vendor the new library. but we don't really have a formal system for broadcasting announcements. It's up to the developer of the repo to pull in updates if they want them.
Yeah, it's usually just at here in the Golang channel, like, hey, FYI, you should look at this new update. If it's like a hotfix or something, then I think we've been a little bit more formal about notifying people.
It's a good question. It's something that we've thought a lot about and we haven't found an easy solution to yet. Anything else? Okay, fantastic. Thank you guys so much for coming. It's been good to have you here.